Hello, welcome to MongoDB TV. This is the Cloud Connect Hour, and we're going to be talking about semantic kernel, AI, vector search, all kinds of good stuff when it comes to MongoDB and development. But before we jump right into those topics, I want to introduce some of the people on the stream. So we have Prakul, who works for MongoDB on product side. We have Tim Kelly and Anaya Rezingani, who are developer advocates who work with me, and we're going to be showing you some cool stuff. But logistics-wise, before we jump into it, I want to reiterate that we're live. We're live on YouTube as well as LinkedIn right now. So if you drop us comments, if you want to engage with us, if you have some questions, please do. We will address anything that you type in. If you just want to say where you're tuning in from too, that works as well. And we're going to be sharing some links as we progress. Anytime we reference a particular piece of documentation or tutorial, we'll share those in the stream as well. But diving right in, so I'll kick it off to Prakul here. What does MongoDB offer in terms of vector search and AI? What kind of features and functionality?
Yeah, hi Tim, hi Nick, hi Ananya. So very excited to be here. So let's get into it. So super exciting space of AI. I think that's top of mind for everyone. What does it mean for you? What does it mean for your products? What does it mean for your business? So we are hearing and seeing a lot of excitement in the field in all shapes and sizes. So for MongoDB, the recent offering we have is Atlas Vector Search. That was released a while back, and we have been seeing some amazing applications being built using that. So what Atlas Vector Search does is essentially ability to use these embeddings, what are called vector embeddings, built using large language models, bring that power to your personal data, such that you can actually do things like search your data in natural language in a variety of languages, even without having the data underlying there, to building these more sophisticated applications, which are called RAG, Retrieval-Augmented Generation. So there is a
Real
lot.
quick, Prakul, do you want me to share your screen?
Yeah, that's actually,
All
I
right,
have some
there
pictures.
you
So,
go. Perfect.
all right. So, yeah, let's actually dive in to this. So, so first thing is like essentially the native vector search, right? So the power is really with the metadata, all the text and other data that you have along with these vector embeddings that comes with it, right? So Atlas Vector Search allows you to essentially take your operational data in cloud wherever it is already is. Couple of clicks or API calls will create this vector search index, which essentially powers these KNN queries. And these KNN queries really are these approximate nearest neighbor search queries, which allow you to um, do some of these things. I'm going to go into details of what that means. But essentially, all this comes out of the our integrated power and fully managed platform that is MongoDB Atlas. So just to make it a little bit more real, what does that mean? So with MongoDB, you essentially get, so in this case, we have an object, we have a document where it's talking about a stock symbol, some hypothetical company, we're talking about the quarter, we're talking about date, and there's some content associated with it. In this case, their call, which is basically talking about, hey, ladies and gentlemen, thank you for standing by. So now with this, if you really wanted to search across what happened really with this company, right? What happened in this earning report? Keyword search would mean looking for those exact words, right? You would just, on the content field in this document, you would search for those keywords. So things like, ice cream, gelato, dessert, like all of these things mean the same thing. But if you were doing a keyword search for ice cream, you will not find gelato, right? So semantic search essentially means it is based on the meaning, the intent. So that's what vector search allows you to do, right? And the document model, your vector embedding, which will be created using a model, a large language model, sits right alongside it. So this essentially means once you have those data in, you would create a vector search index where you would define a key index field. you will find the dimensions of your vector links. We'll talk about what does that mean, and we find a similarity function. Alongside that, you would define other fields, your date, double, whatever you want to.
Hey, Prakul, just to interrupt you real quick, I think you're having a little bit of a network hiccup right now from your hotel room. I don't know if we want to come back to you when things stabilize, or if we want to keep trying. This is a question for people watching the video live right now with us. Are you able to follow along, or is it tough from the network problems? Maybe keep going, Prakul, and I'll stop you again.
Yeah, I can just continue talking if it's not a good.
Yeah, for sure.
So once you have your index created, you essentially go ahead and put out your vector search. So there's a $vector search syntax, which allows you to query across these vectors, as well as define some filters to do more of traditional point and range queries. So this kind of a capability essentially becomes really powerful. And today we are super excited to be announcing our integration with Microsoft Semantic Kernel. And that allows developers to really accelerate the pace of innovation that they're able to build using these tools and technologies. So, yeah, Nick, did I answer your question? What can I double click on?
Yeah, it sounds good, man. Is there anything that Tim or you wanted to add to this, or to kind of set the tone of the discussion for today?
Yes, so I'll pop in with that. So in terms of what vector search is doing for this, how does this relate to a RAG application, which is something we're going to be building and explaining later? So how does that integrate into what we'll be doing with Semantic Kernel?
Yeah.
This is a question for you, Prakul, I believe.
So yeah, just to get onto that, right? Like, so essentially the AI ecosystem, right? So the question is like, how does this ecosystem come into picture? What does Semantic Kernel do? What does it mean? So on top are essentially these AI orchestration frameworks. So LangChain, Llama Index, Semantic Kernel are those popular ones. On the middle are these SaaS APIs for your large language models, your embedding models, and then there are these open source models, which are available on a repository like Hugging Face. So now essentially we talked about the vector search that's powering your data, and we talked about these models that have all these capabilities, the AI capabilities. As a developer, as you build, you have to orchestrate calls to your database, orchestrate to your vector search, to getting those data back, put that back into some prompt that you would feed into a large language model, get some response back, do processing with it, to finally get to your end result. So all the ecosystem essentially is where Semantic Kernel really helps out. So Semantic Kernel from Microsoft is built on their experience with building out these Copilot products that they have been doing. So it brings together your plugins, your capabilities, some of the abilities of the large language model, the agentic behavior to be able to orchestrate things, to be able to reason stuff. So bunch of stuff to get into, but yeah, I think as we go through the second part, which is a demonstration of building a RAG application, which Anaya and Tim are going to walk us through, it will become much more clear of what that means. But yeah, that's the spiel on what we're doing today. Nick, you're mute.
Good catch. All right. So did we want to dive into some technical demonstrating how to use this with MongoDB? Or is there anything that we wanted to add first?
Yeah, just maybe let me give a quick overview of, we talked about semantic search. We talked about the retrieval-augmented generation. So semantic search is really like, if you were to do this natural query, so I'm like, okay, houses in New Jersey, which have a front yard, which are less than 500K, right? That's what a semantic query is. We don't expect these words to be there, but the intent in the description of that property listing, etc., right? And the other interesting piece, the pattern is about the retrieval-augmented generation, which is basically called as RAG. So for RAG, it's really like a two-stage process, right? You would take your knowledge source, which would be your PDFs, could be your Google Docs, could be your Slack messages, wherever your knowledge is, all the data, which could be text, could be video, could be audio. And you basically take that data, you would put that into the MongoDB Atlas vector search. To do that, you first have to chunk it, which like some segments out of the text, the context window that a model has, so you want to keep it short. Then you would create embedding, right? Embedding is when you pass that part of the text to an embedding model using an API call. These are the OpenAI or Cohere, etc. And then you would store it into MongoDB vector search. So once this is done, the second step is about querying. This is every time that users are using a app, this is what will happen. So now essentially in this case, we are asking a question like, okay, how much better is GPT-4 in reducing hallucinations over GPT 3.5, for instance? So this is something which is a newer question, was not part of OpenAI dataset since it has knowledge cutoff till 2021. So this is based on a technical report which came out sometime this year. So ChatGPT won't be able to answer this for you, right? So now to get to a proper answer, which is on the right, very point blank answer of what that is, right? So you have to do all these steps. You create the embedding, you create the vectors, do the vector search, you get your key results, top matching results, which you would do some re-ranking on based on the similarity score, which MongoDB Atlas vector search will give you. Then you feed these into a prompt. Prompt is something like, okay, just answer this question that user has asked based on this knowledge. If you do not know, just say no. Don't make things up. This prompt is generated, then you would feed it into an LLM, which will give you this specific, well-informed answer, right? So this creates a lot of powerful applications, but requires orchestration, right? And today we will talk about how Microsoft Semantic Kernel helps you in simplifying this process.
So there was a question that came in the chat here, and I'll put it up on the screen. So the question is, why Semantic Kernel and why not LangChain?
So at some level, these have some similar functionalities, some similar constructs. So Semantic Kernel is multi-language support. So LangChain comes with like JavaScript and Python primarily. Semantic Kernel comes big with like C#. Has a big on Python. They are big on Java, and they're going to come out with something for JavaScript as well. So there's definitely that language, choice of language that comes into picture. And then in terms of functionality, so you would find a lot of concepts are very similar in semantic search, and like the planner agent is interchangeable between LangChain and semantic search. So the kind of left to the developer on like what kind of a development experience really works for you, right? So they have some fundamental differences in terms of how you would generate your prompt, how you would make calls to your different skill sets. So there are some of those nuances. So for MongoDB, it's like, we are a developer-first company. We want to make sure whatever tools and techniques our users are building using, we are there, right? We are supporting you on your journey wherever you are. So that would be like a short way of thinking about how would you choose between these frameworks.
Cool. If that doesn't answer your question, just go ahead and type a follow-up. We'd be happy to follow up on that. We got a lot of people tuning in the chat today. That's fantastic. Do we want to dive into some code? We want to show how to make all of this possible and how easy it is.
Yeah, let's do it.
All right. And then Prakul, you're going to stay on for a little bit longer, and maybe we can talk through some of what we're going to be doing today. So Anaya, do you want me to share your screen there?
Let's head over to Tim first.
All right.
Show us how to set up our cluster properly and just give a really great example of what retrieval-augmented generation really is and why it's important before we dive into the demo part of it. So all yours, Tim.
Yeah, so this tutorial takes you through how to use Microsoft Semantic Kernel to properly upload and embed documents in your MongoDB cluster, and then conduct queries using Semantic Kernel. So what we're going to be building is basically, it's going to look like a little Copilot friend. We're going to ask questions, it's going to tell us. So if we start with this one up here, as a friendly AI Copilot, answer the question, did Albert Einstein like coffee? Now, this will take a moment to get back to us, but yes, Albert Einstein was known to enjoy coffee. Okay, now, very historical figure there, bit of significance to him. There's going to be some data out there when you're training your model that's going to be there. Now, if I ask, as a friendly AI Copilot, answer the question, do we like coffee? Now, as significant as we are, I don't think there's as much data out there. So if we prompt that, we're just going to see one of the potential pitfalls that you will see with large language models. So when this gets back to us, as an AI, I don't have personal preference or experience. So unfortunately, I can tell it as much as I want that I like coffee. It's going to take a lot to get it to know that. And that's what RAG solves. So RAG is a method used to enhance your models like GPT by combining them with external knowledge. Now, retraining is expensive computationally, time-wise. So what this does is it allows AI to pull the data, like Prakul was saying, from your own knowledge bases. Now, these knowledge bases can be the entire internet. They can be your own proprietary database with secret knowledge that no one outside the business is allowed to know. And you definitely couldn't give GPT to train their models. So if you think of it like this, anecdotally, if I was having a conversation with you and you asked me, what's the biggest dinosaur? Now, it's been a while since I've been looking into dinosaurs. I'd say a T-Rex. I remember seeing Jurassic Park. That makes sense to me. Now, I have absolutely no source for that. That's probably entirely out of date, but it isn't really important. You know, if this is for a meeting, what I'm going to do is I'm going to say, okay, this probably matters. I'll go to somewhere I can trust, National Geographic, and I'll look it up. I'll find out, okay, the Gigantosaurus is the biggest one. I'm able to give you an informed opinion that's up to date, and I'm able to cite my sources. So traditionally, when you're talking to these large language models, you give a prompt, you get a response. With these RAG models, you give a prompt, that model will then go to retrieve the most relevant documents using our embedding and our vector search. It will bring that in. It will augment its current knowledge base and its current response with that new relevant data, and then it will generate a very up-to-date response. So you can see the use cases for this would be something like building these copilots to help with company documentation, just keeping your models up to date. Now, what we're going to do is, if you can see my screen here, we're going to start by just creating a cluster. If you want to follow along at home, get a project set up. If you already have one, that's perfect, but we'll just call this one kernel. We're going to go next. Now, it already has me added as a member. That's perfect. So create project. So it'll just take a moment. And what we're going to do is we're going to have to create a cluster. If you've done this before, it's quite straightforward. And if not, no worries, I'll take you through step by step. So we're going to go create. For the purpose of this, your free tier M0 cluster is perfect. Now, we'll scroll down, we'll pick Azure, we'll go down. We don't need to name the cluster. You can name it if you want. Cluster 0 is fine. And we'll create. Now, the beauty of making sure a bunch of robots aren't doing this for you is the CAPTCHA, but I think I nailed it. Perfect. Now, username and password. This password is not secure because I've just shown everyone, but I'll hide that. Get your own one. Now, keep track of this because you're going to need it when you're connecting to your database later. We'll just create a user. And then for IP address, yep, it's got my IP. That's perfect. And we'll just go finish and close. Perfect. So, well, that's provision in there. I'm just going to show you how you are going to get your connection URI later. So on your database, it's just connect. We'll go to drivers. We'll be doing this in Python, of course. And here you'll see your connection URI. Now you're going to need to fill in your own password later. So keep track of that. And it's just a copy, just that simple. You'll be adding that in when Nana is taking you through how to actually build your application. The last thing you're going to need is going to be an OpenAPI key. So if you go to OpenAPI's website or OpenAI API website, and we'll just look here for API keys along the sidebar, create a new key. All you need to do is create an account and verify your phone number. They give free credits with your first account. You can do this and follow along at home for free. So
just to confirm, everyone on the stream here, so everything that we do on this particular stream today can be done for free, right?
Yes.
All right.
Absolutely.
Perfect.
100% for free. As Tim showed, you can create a free M0 cluster. Google Colab is free as well. And then, yeah, you can get credits for your OpenAI API key. So there's no excuse why you shouldn't try this out yourself.
Perfect. Now, Anaya, do you want to take it away?
Yes. Let's get my screen shared up. So do I have to do anything on that side? There we go. Okay, perfect. And let me just, I think right now it should be 150, but let me zoom in and see.
We do have a question coming in the chat, but I think it's best if we save it for a little bit later in the stream. It's more on the how do we do the integrations in our own projects, which may be solved through some of the stuff that you're doing, Anaya.
Yeah,
So
I'm
that's why I wanna hold off on it.
Yes, I'm actually going to be taking you through that step by step, showing you exactly how to set up the integration between Semantic Kernel and your MongoDB cluster. So just hold on tight and then we'll get there. It's only a couple of steps down, so it'll be answered soon enough. For the first step, so before we begin, I kind of do want to talk about Google Colab a little bit and just kind of why we're using Google Colab for this demo specifically. For those that haven't used it before, it's really popular in the data science sphere and especially for machine learning. And as you're going to see, it's because you can run each block of code individually. So it makes it really easy to troubleshoot. And it's Python. So it's Python in your browser, which means that I don't have to work locally or download files or do anything like that. Another great part of it is that it has Colab in the name, so it's collaborative, which means that multiple developers can actually work on the same project at once. So with that in mind, let's just jump in straight away and get started. So the first line that we're going to need to just kind of set ourselves up for success is just ensuring that we've installed the latest version of Semantic Kernel, right? So that we're just going to do with a very simple pip statement. And if you've used Google Colab before, if you're in data science, drop it in the comments. Let us know what made you interested in joining this stream today. And then, of course, I'm going to try to go slowly because, live coding, live streaming. I want to make sure there are as little errors as possible.
Yeah, if you have a question for anything that Anaya is doing, any of these steps, please don't be afraid to drop those questions in. We want to make sure by the end of this stream you feel comfortable using any of the products mentioned. Yes,
1000%. Yes, as we're going through it, just drop a comment. If you'd like to follow along too, we actually do have a fully fleshed out tutorial already written in article form, so with great explanations from myself, Tim, and Prakul. That's on our developer center, and I think that we'll drop that in the chat if you'd like to see it, read about it, or just bookmark it for later. But now, so we have successfully run our first install semantic kernel command, right? The one thing I want you to look out for, I know there are a lot of requirements that are being downloaded here. I just want you to make sure that PyMongo is among them because PyMongo is our Python driver, and so it's very crucial for this demo. So now once that is done, we are going to go ahead and we're going to actually set up the imports that we need for this tutorial. So in our imports, we are going to be importing in our text embedding along with our MongoDB Atlas memory store. So let me get that set up and then I'll talk about it as I'm doing it. And once again, feel free to follow along. Inside our article, we actually do have a link to the Google Colab file that we used to build this tutorial. So if you want to run those commands separately as well, you're totally able to. So here we're just going to be importing in our semantic kernel as SK. And then, of course, we have to import in OpenAI, right? Because that's where our API key is coming from. So we need to make sure that we have that. And then for the next part, if you aren't familiar with getPass, getPass is actually super nifty. And normally, if you're working locally with Python files, you're going to have a .environment file to hold all of your private security information in. With Colab, you can upload files, but it does get a little bit tricky. So our workaround for this is that we're just going to use getPass, and so it's going to actually prompt us to upload not only our OpenAI API key, but also our connection string that Tim showed us how to get before. So I'm going to show you all how to set that up. And then here we're just going to do semantic kernel.connectors.ai OpenAI. And then here we're going to import two very important classes. So our first is just our OpenAI chat completion. And this just has to do with using ChatGPT as our large language model. Sorry, my words are getting away from me today. And then our second one is just going to be for actual text embedding. So that's just going to be OpenAI and then text embedding, just like that, because we are going to be embedding in the data that we put in along with the queries that we're going to be asking our data. And you'll see that in a second. So once we have that done, now it's time for us to put in our actual MongoDB Atlas memory store. So let me get that up and then I will explain. Connectors.memory. So that is a really great thing about semantic kernel, is that it can be used as a memory store. And you can, there's amazing documentation from Microsoft out about it that I'm pretty sure is linked inside of our article. And it just takes you through semantic kernel and it helps you understand some of the really great uses about it. So let me make sure, import and then MongoDB Atlas memory store. Perfect. So this class is very important because without this, we're not going to be able to actually establish the connection between MongoDB and semantic kernel, and we wouldn't be able to use our cluster that Tim set up as a way to actually hold in our private information. So let's just run that. And I like to just separate our imports versus everything else, just to make sure, like normally in a local file, you have them at the top of the page. This just helps me in case things go wrong, if we need to troubleshoot. So now let's actually add in all of our important information, right? So let's just do kernel is equal to sk.kernel. Perfect. And then open AI.API key. So for all of the other variables that I'm going to be going over, you can come up with your own name for them. But when you're inputting your API key, please ensure that it has this sort of variable name, that it's OpenAI.API_key. Otherwise, it's not going to work. So here's where we're going to be putting in our getPass. And once I run this, you will see exactly what cool thing it does. But first, I'm going to have to go through setting everything up before I can show you. So that is for our OpenAI API key, our getPass. And now we're going to do the same thing for our MongoDB Atlas cluster URI. Great. That saved me some time. So just getPass.getPass. And then once again, just a prompt so that I know exactly what's happening, right? So it will just be like this. And then leave your comments down below if you have any, or any questions or anything. I'll be happy to answer as I'm typing. And then here we're just going to start setting up our actual variable names. So as both Prakul and Tim mentioned before, we are going to be using MongoDB Atlas vector search. And this means that we're going to be incorporating a search index into our tutorial. So in order to do that, let's make sure that we have a proper variable for it in the beginning so that, everything is set up nicely when we need to get to that point. So I'm just going to name it as vector search index so I know exactly what's happening. And the automatic name, as you're going to see, is default. But I am going to be putting some very fun and random facts about myself about myself, Nick, and Tim in here. So I'm just going to call it default random facts. And then now we're going to go through, we're going to do MongoDB database. And this is just going to be our database name, and I'm going to name it Semantic Kernel.
And none of this stuff needs to exist prior, right? Only the index that we're going to create soon.
Yes. And the index, you're going to be creating that as you go along. But once I do this, let me actually show y'all what is in our cluster overview. So this is our cluster. And if I go to collections, I have no data in here. So you don't have to set up your cluster in advance because when you create all of this and you run it, then once you input your documents, your database is going to be created along with your collection. And then the 5 documents we're going to be creating is going to be put inside of that collection. So none of this needs to be done now. You can do it all later.
So we have a question coming in from Sarma.
Yeah.
The question is, why do we use a search index and what's the purpose? And I can chime in a little bit, and you all can chime in too. So we're using Atlas search. Atlas search includes a full text search option as well as a vector search option. And the indexes work a little bit different than the indexes that you might put on your collections for just standard filters or aggregation pipelines. And I know, Tim, I think when you create the index, you're going to be explaining a lot of the different properties of that index and why we do that. But this is just a quick preview right now.
Yeah.
Hopefully that gets you started.
Yeah. We're going to be going through all of that. I have yet to show you how to set up the index yet. So we're going to be diving into that in detail. But for now, we're just putting in our chat service along with our text embedding generation service. So our chat service is just because we're going to be using ChatGPT, and we're using the free version, which is 3.5. But if you have access to 4 or any other version, please feel free to use that as well. We're just trying to make it as available for everyone. And then, of course, the text embedding generation service, we are going to be using a data model that's actually called ADA 002. And so that also is just compatible with our API key. But please check and make sure that you are using one that is compatible with whatever you're using.
How do you determine whether it's compatible? Is this something that's defined in the OpenAI documentation that they're using ADA, or is there something else?
So if I remember correctly, when you go to find your API key, you can actually see a list of data models that are compatible with whatever service tier you have. It's either through there or it's like a quick Google search. You can see exactly which ones are compatible. But this one, the text embedding ADA 002, that one I'm pretty sure is just like a baseline compatible one. So if you have like a free tier, a free version, you should be able to use this one. But there are a ton of data models out there, and it all really depends on your use case for what you want to use.
That's what I was going to ask. I was going to say, how do you know which one you should use? Is there a benefit?
I mean,
so this is just basic.
I think that this one is the most basic one. There are other ones that I think are different based off of if you want to embed or look up embeddings based on more for like songs or pictures. I think that's correct. But yeah, I would say just look around their website. There are a ton of data models that are available to be used. So you can try one out, try different ones out. I know when building this tutorial, we tried out a couple and we just decided to use this one because it seemed to be like the most well-known one. But yeah, I guess it's kind of like pick your own adventure. And if it doesn't work, like you can always just use another one. Yeah, you can try it out.
Got it.
Yeah, so we have that in place. And then now let's actually set up our memory store. So let's just register a memory store. And this is just going to be kind of repeating in our variables that we did above. So we have MongoDB Atlas memory store, right? Perfect. And then from here, now we want to do so these are all of the variables and all of from up here, all of this section that we need to put in to make sure when we establish the connection, we are inputting our documents in the correct place and we are having, everything line up the way that we want it to line up. So we have our index name, right? this is the index that we're going to be using, MongoDB Atlas vector search index. And then now we need to do our database. So we can do that with just database name. We'll keep things really easy for ourselves. No need to complicate it. So MongoDB, and this one was just database, right? Perfect. And then we need one more, and that's just going to be our connection string. So connection string, and we had that as MongoDB. I think it was Atlas cluster URI. Great. And the URI thing is just another way of saying connection string or cluster. So don't let that confuse you if it is. And then we just need one more to import.
And in typical scenarios, the all caps constant variables right here would be in an environment variable. Right?
Yes, yes. Yeah, it would be in an environment variable. Yeah, and you can choose like whichever name you want for it. But if you do decide to not follow along with the variables that we've chosen, just please make sure that they're the same throughout. Otherwise, you will get errors. But yeah, the ones in all caps, you can make whatever you want. Just for your API key, please make sure that it looks like this. Otherwise, you will get an error. So let's run this and see with get pass, it's going to prompt me. So that means that I don't have to show my keys or anything else, which is awesome. So I have that off screen. Let me input that. And now same thing with my cluster because
we just saw your OpenAI key. No, I'm joking.
Oh my God. See, I'm not looking at.
I know you're not looking
at the stream, and so I was like, wow, give me a heart attack there. Okay, you'll know that it works when it tells you that it works. But so this is great. So now we've established a connection, but let's actually put in our documents, right? That's the whole point. So add another code block, and we can just do async def populate memory, because that's what we want to populate our memory store, and we want to do sk kernel. Great. So now let's add in some memories, or let's add in some documents to our semantic memory. So we'll go await and then kernel.memory save information async. And for all of these commands, they are available in the Semantic Kernel documentation. So if you're looking at this and you're like, where are you getting that from? That is where we got it from. So then here, also for documents, when you're saving them in Semantic Kernel, they do have some already filled in fields for you and some automatic fields. And so you can just like play around with that while you're building out your application, or if you're putting in documents. So for example, you're able to specify exactly which collection you want your data to be in, but you aren't able to specify database, which is why in the beginning we just did both just for easeability purposes. And you can have an ID per document, and Mongo actually does that automatically for you as well. But yeah, just little things here and there, and you can actually see exactly what is allowed and what's available in their documentation too. So please feel free to check that out as well if you have any questions, or just ask in the comments and I'll answer it if I know the answer. So let's set it up, and then we'll put in some information. So let's keep that blank.
Do you want to reiterate? We have a question here on what we're trying to achieve. Do you want to reiterate, just in case somebody's coming in late or somebody's missed part of it, what our goal here is with Semantic Kernel?
Yeah, so yes. So what we're trying to do is right now we're building out a demo with the idea of adding in our own personal information, because a lot of large language models, they have cutoff dates, right? So let's say that you are a big company and you are building a chatbot for your own personal information or to find information faster. With Semantic Kernel, you can actually populate your own data into a database like MongoDB, and then ask questions based off of the data that's in there alongside the data that's widely available. So let me know if that answers the question.
Can I throw out an example, and you all tell me if this is like a stupid explanation of it?
Yes.
Like let's say that your organization has an internal wiki page or documentation for staff, and you want to be able to search alongside that as well as the data that's publicly available, right?
Mm-hmm.
So you would load all of your internal site data, your org data, into the semantic kernel, and it would then save it to MongoDB, so that way you can search over it as well, correct?
Yes.
That could be an example.
Yes. Yeah, perfect. That could totally be an example. And the cool thing about it is, if you want to go into a little bit about RAG, I'm not sure if Prakul is still on the stream, but maybe for those that are late, that haven't heard of RAG before, we can dive into that for a second while I fill in the text.
Yeah, absolutely. Yeah, sure. So RAG is Retrieval-Augmented Generation. So in terms of what we're building here, that's what Nick was saying, we're able to augment our answers that we're giving from the large language model using our own data. So retraining these large language models is expensive, computationally, time-wise. That's why there are those cutoff dates. And if you use ChatGPT a lot, you're familiar with, I think the last time was June or April, and it will tell you, I can't give you anything from September 2023 because I just don't know about it. What we're doing here is we're able to add that. So you prompt your large language model, you ask your AI copilot that we're building here, you'll ask it a question. What it will then do is it will search in what's our MongoDB Atlas at the moment, but it could be your own document store or whatever you have. It will search that, it will embed using vector search, and it will retrieve the semantically similar content from your database, bring it back, and then it will use that to augment its own knowledge and will generate its return, pass that back to you.
Perfect. So any more questions, just, drop them in the comments. We will answer them. And while Tim was doing an amazing job of explaining, I went ahead and I filled in some fun facts about us. And so those are just, our names. Our names are Anaya, Nick, and Tim. Some things that we like. So we like Pete's Coffee, Starbucks, and Mountain Dew. And what team are we on? We are on the DevRel team. Where do we live? New York, California, Ireland. And we are all so excited to be demoing this live for you guys. So let's run this, and then that worked, yay. But now let's actually populate in our memory. So once again, what does that mean? That means that we're going to be putting in these documents into our MongoDB cluster. So first, let's just do a little so that we know what's going on. I'm just going to say populating memory, and that's just adding in our documents. And then we can do an await populate memory kernel. Awesome. And then we can just print out our kernel just to make sure that we know what's happening. And we can run that moment of truth. Yay, and it worked. Okay, but let's not just take Colab's word for it. Let's go check out our previously empty database and see if our documents are in there, and they are. As you can see with the database that we created, it is now called Semantic Kernel, along with our collection that is called Random Facts. And as you can see, we have 5 documents in here, right? And so let's look at the first one. The first one, it has the text, which is our names are Anaya, Nick, and Tim. And then let's go and make sure that it's actually embedded. So for those who may have not, embedded text or anything else in a large language model before, different models have different dimension sizes, which Tim is going to go more into in a second. But we know that OpenAI, their size is 1536. So we know that they embedded our phrase, our names are Anaya, Nick, and Tim, in an array that is 1536. That is the size 1536. So perfect. Now that we have this ready, we can actually create our vector search index. So for those that haven't done that before, all you have to do if you're in Atlas is go to search and then let it load and hit create search index, hit JSON editor, and then just click next. And so now we're just going to click on random facts, and then I'm pretty sure our name was, what was it, default random facts?
Yes, it was.
Perfect. Okay, good. And then I'm going to copy, and I have it off screen. I'm just going to copy and paste in, and then I'm going to turn it over to Tim, who's going to explain what all of these fun little things mean.
Yep. So in terms of our actual vector search, what we're going to be focusing on here is what's in that fields. So you'll see fields, embedding, that's just the name of our field. and then you'll see type, type KNN vector. So that's k nearest neighbors. That is just a way of representing this data in our nth dimensional space. So with k nearest neighbor, what it says is objects in this space that are near each other are similar to each other. So proximity is how you dictate how related things are. Now, if you think of that in just two-dimensional space, that would be something's up here, something's here. These are more similar than these, just purely by the distance of my fingertips. Now, there's different ways of judging the distance between these. Now, you'll see that in the similarity field, but you have Euclidean, cosine, and dot product available with MongoDB. Now, Euclidean just measures the distance between the ends of the vectors. So this allows you to measure similarity based on varying dimensions. So after that, you have cosine. Now, cosine, the difference between cosine and Euclidean is it allows you to measure similarity that isn't scaled by magnitude. So if you have 2 points going away from our origin in the center, now they're both following the same line. We have 1 point here, 1 point here. They're both just as similar as each other. Now, what we have after that is we have dot product. Now, dot product takes into account the magnitude of the vector, but it will also measure the distance. So you take into account both angle and magnitude. We're using dot product in this case. Depending on what data you're using, you're going to want to use different similarity methods. Now, if your data is, if magnitude matters to you, cosine will be the wrong one to choose. If Euclid, or if the actual distance between the points is what you're prioritizing, so in terms of actually measuring text, semantically, that is what we're looking at here. So yeah.
Perfect. Thank you. Yeah, and if you have any questions about vector search and all of that, let us know. We have some really, really great resources that we can send your way in the chat and show you, so you can get a better understanding of what MongoDB Atlas vector search really is.
I have some questions popping in the chat, so maybe we take a moment to address some of them.
Yes.
And first of all, I apologize if I missed your question. It seems like some of the questions are coming in at weird random times that are not in order. So it might be some kind of technical glitch. But the first question I have here is how do you find which embedded model, what the size is? Where does that 1536 number come from? Is that standard?
It depends on what model you use. So it is very important that you know how many dimensions it is when you're actually querying and embedding against it. And because it's so important, APIs will always specifically tell you and make it as clear as possible. So OpenAI lists it in its documentation. And also, if you've embedded your data already and you're querying off someone else's embedded data, a quick way to check is you can actually just see the array size of the embedded field in your database. So we saw there 1536, but it will always tell you how many dimensions it goes to.
Yeah, and if it doesn't by any reason, you should Google it. Just make sure, because it's super crucial. And when you use vector search, you're gonna have to specify. And normally if you're gonna be embedding any sort of content or data, they'll tell you, you'll know. But for OpenAI 1536, because I feel like a lot of people use OpenAI. There are some other very popular and famous ones, but OpenAI is, cream of the crop right now. So just keep in mind 1536.
I have another question that came in, and this one might be more opinion based, so I'll let you all chime in. I'll read it to you just in case you don't see it on your screen. Suppose an organization has documentation in a CMS like Sitecore or others. Are you recommending that we move these docs to MongoDB with vector search? Suppose an org has 100,000 documents, or I guess documentation documents. Is this model still applicable or recommended? And do CMSs nowadays have this kind of stuff built in?
Okay, I'm reading it.
It was a long one.
Yeah, I would say, of course, always, whatever you want to move over to MongoDB, you totally should, my unbiased opinion. But, it depends on each use case if it'll make the most sense. I feel like for a question like this, if if you're considering it, you might want to talk to someone on our team who does design reviews or who can take a look at the way your data is stored and your data model looks and see if it makes sense. But yeah, I would recommend, of course, like we have so many resources out there, and then also Atlas, MongoDB Atlas is free if you just want to try, give it a shot, see if it works, if it makes sense for you. But yeah, I don't know if you want to add anything to that, Nick.
No, I'll let you guys take that one. And if there's a follow-up question, I'll let you know on that one. I also have another question here. I don't know totally what it's asking, but may I combine DB CRUD queries with vector search?
Will you say that one more time? DB which queries?
CRUD type queries. So create, retrieve, update, delete queries with vector search.
Yeah. I mean, you can do any, like vector search is just kind of an addition. For like a simple CRUD application, you can totally incorporate vector search into it. I'm not sure if that answers the question or not, but
yeah, Han, if you have a follow-up to that with more context, absolutely, please drop it in the comment.
Yeah, and if right now, we're talking about vector search and it seems like, an unknowable, you're not understanding what it is, we have so many resources on not only our developer center, but also just on the MongoDB website that'll show you examples of what it is, how to do it yourself, how to set it up properly. So please take a look at those as well. But yeah, for like a CRUD application, you can really incorporate vector search for so many different uses, because vector search really is a way of searching semantically, so based off of meaning rather than like specifically for words, right? So a good example of this is like, let's say you can't remember the movie title, but you remember the plot of the movie. You can search based off of plot, and then you'll get results that way. Whereas with, normal text search, if you don't have a word that immediately hits, you won't get those results. So when you think of semantic, think of, searching based off of meaning instead of searching for like specific exact words. And so any kind of application that you want to build that you think would have that as a use case, you should totally try to incorporate vector search in, because it's just cool. I think it adds like an extra element. And we have so many examples out there. You can follow along and try it out, see if it works for your use case, for sure.
And then one more thing before I let you continue as well.
Yes.
We got a comment questioning the efficiency of the code that was being presented. I just want to reiterate that our goal on this particular stream is not to write the most efficient code. Or the goal is to make it as easy to digest as possible, and then you could go on and make it as efficient as you want later. I know I posted that response in the YouTube chat, but I don't think I posted it in the LinkedIn chat for people watching from LinkedIn. Just wanted to clear that up.
I know probably I'm assuming it was about this part, like the populating memory, adding in your documents. Okay, yes. That's just so that like we can all know exactly what's being asked, and we can just see it in order, know that there are 5, like for someone that might be new to Python, because this is like, Google Colab it's all Python, and then this too is all Python. I just want to make sure that we're all on the same page. Of course, if you're doing it yourself, like I wouldn't say write out every single document, but just for the sake of this stream and for the sake of this tutorial.
And while we're on the topic of this stream, if you haven't already, hit that like button on the YouTube channel, and I think you could give us some kind of like on LinkedIn as well. Also, follow or subscribe to our channel, so that way you catch every stream that happens after this. We stream about something, I think, weekly or multiple times a week. So it's good stuff to learn about. Yeah.
Perfect. Okay, let's ask questions, right? So if you remember from Tim's example, we were able to see if Albert Einstein likes coffee, but we weren't able to see if we liked coffee, right? So let's ask just some questions. Let's start off easy with what are our names? And let's see if it gives us a result. It's going to tell us which document it retrieved along with the relevance for how relevant it is out of a score. So awesome. Our retrieved document was our names are Anaya, Nick, and Tim. with a score of 0.93, which is great. So now let's do the coffee question. Do we like caffeine? And I think that's how you spell caffeine. And awesome, we like Pete's Coffee, Starbucks, and Mountain Dew. Cool. And then
Just
Nick,
for the heck of it, misspell
Yeah.
caffeine just to see if it picks it up.
Okay.
I think it will, but
I
try it
think
anyways.
I think it will too, maybe. Yes.
There you go.
Perfect. So awesome. And then Nick or Tim, do you want to throw out a quick little question and see what we get?
I would say, are we excited to be live?
We are so excited to be live. And that concludes our demo portion of this. So thank you all so much for sticking around and asking your questions and watching.
We still have more questions though. So
we have more questions. Okay, perfect.
Yeah, let's if we're done with the coding portion, maybe we start addressing some of the questions, or at least the ones that we have the skills to answer.
Awesome.
I know that Prakul had to jump because he's at a conference right now.
Okay,
but anything we can answer, we'll circle back on the forums if you want.
Yes, perfect. Let's do that. Yeah. So
the first question here is: are there any models for voice vector search? I'm not familiar, but maybe the two of you are.
I'm not sure off the top of my head, but I'm sure there has to be, because I know that there are. You're able to vector embed based off of sound. So for there should be.
There are, and also there's a bunch, and it very much depends on your use case. So that is one that when you're coming up with your own project and you're figuring out what you want to do, the more research you put into it, you'll find audio embedding there's a whole rabbit hole to go down there, and it is.
Yeah, and to add to that, so I know that there's definitely image, because Karen on our team has some demos that she's created that lets you search within images using vector search, which is pretty neat. But I assume audio is similar.
Absolutely.
Next one, and I am honestly not familiar with the product, but see if any of you know. Is there a MongoDB Atlas connector for Microsoft Azure AI Search, formerly Azure Cognitive Search? This probably would have been better for Prakul when he was around, but maybe the two of you know anyways.
Yeah, I am not sure off the top of my head. I've never used Azure AI Search, but if we do have it out there, it'll probably be part of their GitHub repo. So if you're interested in looking for that, I would say check out their repo and get back to us, because I would love to know. But we can ask Prakul and get back to you, definitely, Raphael.
Yeah. We have a question coming in. Can vector search have the capability of having multiple vector data sources, like maybe some from MongoDB, some from Azure Blob, some from somewhere else? You two are more versed in this space than I am.
I am pretty sure, yes. Can we clarify? Do you mean when you're building the same application, you're taking from different data sources, or just that we can have any data source? Because yes, you can do any data source.
So my interpretation of it is, let's say that you have some vector embeddings inside of MongoDB, some vector embeddings in maybe some kind of flat file on blob storage, and then when you use Semantic Kernel to do an actual search query like we did, do you like caffeine? Can it search across those sources? And I don't know, but maybe it can. Maybe you know.
I'm not sure. Tim, do you know?
I'm not off the top of my head. I don't, but
we'd have to dig around.
Yeah, that would be really cool though. Maybe we can build a tutorial around that.
Absolutely.
Yeah,
there's not one already. Yeah.
Great, good follow-up content. What else we got? Is semantic and vector search available with MongoDB Community Server? No, it's part of Atlas Search. So you're going to want to be on MongoDB Atlas, so our cloud solution, in order to use it.
Yeah.
But you can use it for free.
Yes.
It's part of the free tier.
Atlas is free. So if you're new to MongoDB also, you should totally check out MongoDB Atlas.
Question coming in, is today's demo can you do it without? I think it's saying, can you do it without OpenAI?
Yes, you would just have to make the little changes throughout based off of which large language model you're using for your API key. I've never actually used like Hugging Face. I've never used their API keys, but I'm sure you can. Yeah, you just have to make like little changes here and there.
Cool. I think that sums it up for the most part of the stream. I think this might be a good stopping point. I want to throw up this this URL right here. This is a tutorial that Tim and Anaya and Prakul all contributed to. It's found on the Microsoft site. So if you wanted to do some copy paste with what they provided to get this working in your own application, this is a great starting point for Semantic Kernel. If you wanted a good starting point for vector search in general with MongoDB, this is a great tutorial for vector search on the MongoDB Developer Center. So both of these would be very valuable to learn about if this is the route that you plan to go for your organization or your projects. And then finally, we have the community forums. So if you do have questions outside of this stream, drop them in the community forums, and one of us will probably stumble upon it, and we'll be able to help you out. Anything else? Any closing thoughts before we break?
Yeah, if you all enjoyed this, please, follow us on LinkedIn. It's just our names. Leave us comments, connect with us. And every week, as Nick mentioned, we do have a live stream. Stay tuned also with our Developer Center as we have new content coming out pretty regularly. So yeah, thank you all so much for coming and for your questions and for being so attentive.
Awesome. See you later, everyone. Have a great rest of your day.
Thank you.